simplifying expression, proving identity, and solving equations. The three types, right? And then we're gonna go through that. So we did the expression, right? Simplify the expression. What you wanna do is you don't wanna solve for anything, right? Just try your best, simplify it as much as you can, right? Today we're gonna do in verify identity, meaning you're going to prove that the left-hand side is equal to the right-hand side. How do I do that? Well, pick a side, right? Usually the more complicated one, and then prove that side to be equal to the other side. That will be lecture today. Verify trigonometric identity. Well, I know it's trick, but you do need some background knowledge of color algebra. It's kind of help you to relate it, how to simplify one of the sides of the identities. So for example, like algebra, example 1 here, I can factor out, I'll talk about this one. I can factor out the cosine x, right? That's a common factor, just like you did with factor out in u over here. So on the right-hand side, I can factor out cosine x. Oh, sorry, Shade. Okay, yeah, let me do that now. My bad. Is it 32 or 31? I forget. I don't remember. Today is 5th. Yeah, the 5th. It was 33, lecture 33. I put 32. I'll fix it later. I think I can fix it now. Right, Zoomer, if you refresh your Moodle, you should be able to see the lecture notes link. Thank you, Shade. How come it's not? All right, I can factor out cosine x. So what's left for the first term? Well, cosine x factor out, so it's just 1, right? Minus sine x. And how do I check this? Distribute it back to see you get the original one, right? Cosine x minus cosine x times sine x. So you got it right. For the second one, what should I factor out? Is there any common factor? No, right? There's no common factor. There's the first two, but then the last one is not common factor. When you see something like that, I want you to relate it to quadratic, right? I see square and then not square and then a constant, right? So remember what I said, psi square x, I can rewrite it as what? Psi x, all of that square, right? Minus psi x minus 2. Think of it. Usually I show you how to use substitution. So think of it, that's your u. So basically is u square minus u minus 2. Right. For many of us, we like to factor u square minus u minus 2 as opposed to the psi function, right? So same thing when you factor out, you have two binomial. I want psi x all of that square. So what do I need? Just like u square, right? I need u and u. So that means I need psi x here. Psi x times psi x is psi square x, right? The last term, I want two number multiply, give me -2 and add to -1. Well, they're 2 and 1. That's only, and then because the sum is negative, so you gotta have a -2 and then +1. Does that make sense? If it's too hard for you, you use substitution. Whatever inside the parenthesis, you let it equal to u. Number 3, cosine squared theta minus sine squared theta. This is the same thing as cosine theta, all of that square, minus sine theta, all of that square. And again, let me remind this, I talk about this. Sine square t, it is not equal to sine t square. So this one, the whole function being square, right? This one, the only thing square is what? The input angle, the t, right? So be careful, they're two different things. And the left one is equal to psi of t, all of that square, right? The whole function being square. Think of it, same thing, think of it. The first one is u, that's your u, and this is your v. U squared minus v squared, you know how to do that, right? U plus v times u minus v. So in this case, u is cosine theta. So cosine theta plus sine theta times cosine theta minus sine theta. So far, so good. Is that okay? I just this is just reviewing for the next step. Of course, you're not gonna have something like this on exam, but during the exam problems, you use these. All right, next one. Let's talk about this left hand side first. Let's just review your algebra. If I want to factor u squared minus 2uv plus v squared, now it's hard to factor in that form. My trick is that what I did is I ignore the v part. So for the v part, ignore it. Just grade out for a second. What is the coefficient of v squared? 1, right? So I have a number 1 there, but then now ignore the v squared. So basically, I'm factor what? U squared minus 2u plus 1. Everybody know how to factor that? U times u is u squared. I need two number multiplies 1, so just 1 and 1. Add up to -2, so negative, right? And then what do you do next? You plug the v back. That's the trick I taught you, right? Like very first exam one, right? And then now you put the v back. Right? We're gonna do the same. We're gonna ignore the second. We're gonna ignore the second variable. We're gonna ignore the side theta, right? Of course, this in front of side square theta is a 1, so I just leave it there. Can someone factor that for me? I meant this one, cosine square theta minus 2 cosine theta plus 1. That's the one that we factor now. Can someone factor that for me? One step at a time. One step at a time. Yeah, go ahead. No. In terms of cosine. In terms of cosine. Yeah, cos, right? Put down cos first. Cosine theta. Because what do you need? You need cosine square theta, right? This time this is that, right? One step at a time. Now I want you to find two number multiplies 1 add to -2. Yeah, -1, -1, right? So -1, -1. And then you check. Don't write this step down. Cosine times cosine is cosine square theta. -1 times -1 is +1. And now you check for the middle term. Negative cosine give me -2 cosine. So I'm checked, right? All you have to do is what? Now you plug in sine back and then you're done. And then you can check, you can FOIL the back. I'm not gonna do it here. I don't have time, but you can do it at home. Now, if I give you something like this, by the way, does anyone have a question on this one? It's just review and factoring. All right, let me ask you something. If I give you something like this, a squared plus b squared, what do you say? Say that's your final exam question. What would you say? Can I factor it? Is it equal to this? I hope nobody's saying this. No, right? I hope not, because this is what? This one is a plus b times a plus b. And then if you FOIL it, you can have how many terms? 3 terms, right? A trinomial, where I only need binomial here, right? So prime, right? It's not factorable, then it's prime. Do you remember that? Same thing for trig, right? Now, if I have a cubed plus b cubed, now different story. A cubed plus b cubed is not prime. Right? It's factorable. And in this case, it is like this. A plus b times a squared minus ab plus b squared. So you can remember how to remember the sign. What is the acronyms? SOAP, right? SOAP. So same. So here same. Opposite, always positive. So, right. So that's algebra reviewing. Let's apply to trig. If you forgot, here's your sine theta is, imagine that's your A, and then cosine theta, that's your B. Right, now all you have to do is just fill it in, right? A plus B. A plus B, so sine theta is A, plus B is cosine theta. And then the next part is A squared. A squared means sine square theta. Minus A times B minus sine times cosine. Sine theta times cosine theta plus B squared, so cosine square theta. You're done. I want everybody to try the last one. Oh, one more thing. I'm sorry. We're not done yet. Can the factor form be simplified using Pythagorean theorem? Let's talk about one thing at a time, right? In mathematics, if it's something hard, break it down to smaller parts, and then you work on one part at a time. Right? That's the trick. So for the first part, the binomial part, I have sine theta plus cosine theta. I don't think anything I can do with this part, can I? No, right? It's just it. Right? It's just simplify. What about the trinomial? What can I combine and then simplify? What's sine squared theta plus cosine squared theta equal to? 1, right? 1. So that sum is 1. So 1, and then bring down the product negative sine theta times cosine theta. That's what they meant by using Pythagorean theorem to simplify. And now we finish. I want you guys to do the same thing for the last one. I'll walk around, see how you do. Bless you. By the way, we talked about writing up the final exam last night, and then we decided that half your final exam will be from after exam 3 material. So this is not the time to miss the class, right? It makes sense because we already test you on the other exams, right, for the previous materials. So 1/6 will be from exam 1, 1/6 from exam 2, 1/6 from exam 3, and then 1/2 from post exam 3. Right? That add up equal to 1. I'll make sure your final exam have no more than 20 questions on it. And I also finished grading your exam 3 yesterday. I sent it to Sarah and Jeff. Hopefully they'll finish by, I want them to finish by Friday. But I don't want to, rush them. So Monday will be the latest. Okay, I'll send emails to them if Sunday night they're not finished, or Saturday night, because I want to give it back to you, and then I can tell you what grade you have. Yes, yes. Whatever you say, you see side square theta plus cosine theta is always 1. And you say yeah. Wait, so was that? Only square, yeah. Okay. As long as you see the formula. Same thing with your exam 3. I'm going to send out the final exam formula for you beforehand, so you get used to it. So most of you got it right. A binomial, which is sine theta minus cosine theta, slope, right? Slope, same as the original. And then a squared will be sine squared theta minus a times b, so sine theta times cosine theta, plus b squared is cosine squared theta. That's plus, sorry. So same opposite with the original, always positive. So, right. One more, right? We're not done yet. We're gonna simplify it all the way. Like the step before, sine squared theta plus cosine squared theta is 1. So that's 1 plus sine theta times cosine theta. And now we finish. I like to put the equal sign in front to this expression. Let's take a look at this one. Now a bit more complicated. All right, for the top, what can I factor out for the top? You guys done this before. Someone tell me what can I factor out for the top? Yeah, cos what's it? Sine. Plus, right? Plus sine theta times cosine theta minus sine theta, right? A squared minus B squared. A plus B times A minus B. And then for the one in the bottom, remember what I said about the little trick. Ignore sine theta, right? Replace it with 1 because that's a coefficient in front of sine squared theta. The coefficient is 1. Now you can factor that. Cosine squared theta. So that means the first term is going to be cosine theta. If they multiply together, give me cosine squared theta. Two number multiply is 1, add up to -2. So then -1, right? And now you plug sine back. With a little trick earlier, right? Can I simplify something? Is there something that I can simplify? Yes, right there. I didn't, well, there's cosine theta minus sine theta is the same thing cosine theta minus 1 times sine theta. So my final answer will be cosine theta plus sine theta over cosine theta minus sine theta. Let me ask you something. Can I simplify this? Can I? Huh? No, right? Remember, if I have x plus y over x minus y, do not cancel. No, right? Remember what they say, they marry, right? If you see plus minus, do not cancel them. Only multiplication. So you're done. You're done. Any question? Any question for this problem? All right, here is 99% of students get it wrong on the exams, at least for exam 2. It's called complex fraction, meaning you have a fraction on top of another fraction, hence complex. My suggestion to you is you should have one fraction on the top and one fraction on the bottom. All that's your model. Always do like that. So I have one fraction on the top here, I'm good, right? But on the bottom, I need to convert it into one fraction as well, because right now I got 2. Right? So let's take care of the denominator. I'll use blue for this denominator. Let me rewrite this. Cosine theta over sine theta plus sine theta over cosine theta. I'm just rewriting the denominator. I need to add those 2 fractions together. So what's my LCD? Yeah, sine cos, right? So the first fraction missing cosine. So I'm gonna times the first fraction by cosine theta over cosine theta. Remember, this is expression, right? You need to multiply by 1. And the second fraction is sine theta over sine theta. I did not change my expression. Now my expression have the same common denominator, which is sine theta cosine theta. I can add the top. I can add the top. The top will be what? Cosine theta times cosine theta is, yeah, cosine theta square, cosine square theta, sorry, plus sine square theta. What's cosine square theta plus sine square theta? 1, right? 1. If you forget anything, that's the thing you should remember. So now I achieved my goal. I changed that denominator into one fraction, right? Now we put it back together. So the original problem, I have 1 over cosine theta. And the denominator, we simplify it into 1 over sine theta cosine theta. Don't write this down. If you have a over b divided by c over d, flip multiply. This same thing. So 1 over cosine theta times, flip multiply the second fraction, sine theta cosine theta over 1. Simplify, simplify. Your answer will be just sine theta. Any question? This is important. This is important step. I'm reviewing you of these little steps so that we can go to the big problem later. C. Tell me, what should I do? I already told you what I did. Now you repeat it yourself so that you remember. No, it's not the fact that you tell me, but more like I want you to repeat it yourself so you remember. What should I do? For what are the step? When you see complex fraction, what do I say you do? Yeah, make into one fraction, right? So one fraction on the top, one fraction on the bottom, right? So that's your goal. So one fraction, one fraction. So let's take one thing at a time. One numerator. Say numerator. Let me rewrite the numerator. 1 minus sine square x over cosine square x. Maybe I need some space so I can. The common denominator is, well, the LCD is cosine square x, right? So I need to multiply that 1 by cosine square x over cosine square x. Now I have a common denominator. I can subtract the top. cosine square x minus sine square x. All right, one fraction, I'm happy. All right, one fraction, I'm happy. Now, many of you will naturally, you would, you said, can you simplify the top? The top. That's a squared minus b squared, right? Yeah, but let's just wait. Okay, we can wait. Let's wait. Maybe we don't need it. Maybe we need it. We can always simplify it later. Let's take care of the denominator now. Because I don't want you to wait all that time, simplify it, and then at the end you don't use it. The denominator is gonna be 1, let me leave a little space. 1 plus sine square x over cosine square x. Very similar, all you have to do is, it's just different, there's a sign in between. So multiply the 1 by cosine square x, cosine square x. Now I have a common denominator. I can add the top. And then the top equal to 1, right? All right, that's all go. One fraction on the top, one fraction on the bottom. Now we put it together. So numerator over denominator. So the numerator is this, the denominator is that. Cosine square x minus sine square x over cosine square x. So when, because the denominator is a fraction, can I go ahead and multiply by the flip of that? Is that okay? Because I don't want to rewrite the whole thing again. So multiply by the reciprocal of the denominator, which is cosine square x over 1. Is there anything we can simplify? Yeah, cos, right? Simplify that with that. Your last answer is cosine square x minus sine square x. See, that's what I meant by wait till the last minute to see if you need it to expand, right? Because I don't want you to spend all that time and then at the end, oh, I'm not using it. I have to put it back. All of that we just did, all of those, we're gonna reuse it. I'm not gonna go through this again for objective 2. Oh my God, there's more. Oh no, that's done. I thought that more simplification. No, we go to the real deal. Verify identity. All right, that's for you to read. That's for you to read. All right. Direction between distinction between expression and identities. Again, expression does not have an equal sign, so you try to simplify it. Do not solve. Right? Do not set it equal to 0 and solve. If you multiply the expression by fraction, that fraction must be equal to 1, like I've been doing. Cosine theta over cosine theta, sine theta over sine theta, things like that. Now, as for identity, it's contain an equal side. How do I verify identity? So identity is mean 1 to show, WTS is 1 to show that the left-hand side equal to the right-hand side. That's your goal. Right? You're not solving either. All you do is just try to prove them equal. How do I do that? Well, select the side of the equation that appear more complicated. It's easier for you to work with. You can massage them, manipulate them, move them things around. Use algebra and trigonometric identity to change the side you selected, like we've been doing, right? Factoring, Pythagorean theorems, things like that. If you stuck, do it again. right? Use different approach. But I would suggest sometimes you need to look at the other side to get an idea of approach. Right? Just look back, say, okay, maybe I should do something else that I can get the result like this. When proving identity, never cross multiply. Never cross multiply. Because that doesn't mean you solve it. So far so good. That's a little thing that you need to notice. All right, let's get our hand dirty and do it. I need to prove that the left hand side equals to the right hand side. What side you think I'm gonna pick to start with? Which side? Left or right? Left, right? It looked more complicated to me, right? It looked more complicated, so I'm gonna pick the left hand side. So what I'm going to do, I'm saying LHS, left hand side. So I tell my readers, say I'm picking the left hand side. I'm rewriting the left hand side. Okay. Now many of you, if you look at this, you're like, oh, I see sine squared this, I sine square, cosine square, that's 1. What is the problem? Why can't I just do that right away? Because the coefficient, right, is not matching. Remember, you only allowed to do equal to 1 if you have something like this. You need to make it somehow into the same coefficient. So here what I'm going to do, I'm going to split the second one. So I'm going to split cosine squared theta as 3 cosine squared theta x plus 1 cosine squared theta x. 3 plus 1 is 4, right? And then I'm going to combine the first two. What can I factor out for the first two? 3, right? So now I have sine squared x plus cosine squared x. There's my 1. There's my 1. Don't forget the last one, 1 cosine squared x. It's equal 1. Right. 3 times 1 is 3. Plus cosine square x, which is equal to the right hand side. Done. Here is some trick and identity that you should know. If you let me go back here. Now, if you don't remember anything here, at least remember one thing. Remember this one. All of the rest is come from the first one. I'll prove it to you. Just use this one. I'll prove it to you. You don't have to write this down. Just listen to me because it's not going to be on your exam, right? They're not going to make you reprove that. I want this formula. How do I get the one I circle in blue? Well, I'm going to start out with the Pythagorean theorem, which is sine square t. Don't write this down. Plus cosine square t equal 1. I need tangent square t. So I have sine square t there. Sine over cosine, that's tangent, right? So what I'm going to do, I'm going to divide everybody by cosine square t. It's the equation. I can do this, right? Multiply everybody by something, divide everybody by something. This one is, you agree with me, that's tangent squared theta, right? Cosine square t divided by cosine square t is 1. What 1 over cosine square t? 1 over cosine is secant, right? There you go. like I said, everything else is from the Pythagorean theorems. You can manipulate the next one by divide everybody by what? Yeah. I would say, yeah, sine. Yeah, sine square t, right? It's I think I wanted to give it to you on the exam. I think I wanted to, but let me talk about the other two in structure. I know Nicole had no problem with that, just the other one. But we good, we stick together. It's just no use. I don't remember these. Trust me, I don't remember 15 years studying math. I don't remember these. And I feel sorry for you. You have to remember these. Even in structure, I don't remember these. So, all right. But I know how to derive it, right? All right. Next one. What do you think I should pick? Right hand side. Right side, right? Right side. Rewrite it. 2 minus sine square x minus secant square x. Any idea? Okay. Here what I see people do. Okay, they see secant x and then they convert it into 1/, cosine square x. Natural thing. If you all do that, I'm glad you did that. Which is natural. I would do the same thing as a student. But what do I do? But what do I do next? I'm stuck. Am I? I'm stuck. So what I can think of is I'm gonna use one of these instead of changing thing like SOHCAHTOA, right? I'm gonna use one of those identity. Well, the 2 is 2. There's nothing I can do about the 2. What can I change? What can I convert sine square x to? That one, right? That one. All you do that one. So 1 minus, make sure you put parenthesis around it. 1 minus cosine square x. And then secant square x, I can convert it to the one in blue, right? The one I circle in blue. So it'll be tangent square, or do I need to tangent square x? That's a t, all confuse me. Plus 1. So far so good. Now I need to distribute the -1 in front of the parentheses. So 2, just remove the parentheses. 2 minus 1 plus cosine square x minus tangent square x minus 1. The 2 and the -1 cancel, yes. Cosine square x minus tangent square x. You're done. Equal to the left-hand side. So like I said, right? You start from one side and then all equal to the other side. Number 6 is your you try 1. Now this for this class, or maybe for the next a few classes, your you try will be really different. You're going to write your work on the sheet of paper and then scan it into a PDF and upload on it. Okay, and I have to grade it by hand. I know it's more work for you, but more work for me too. I don't like it, but I cannot do it with the multiple choice with these problems. Right? So that's how you're gonna do work on your final exam. Okay. Number 7. Currently, we're gonna pick the left-hand side, right? 1 plus cosine x minus 1 over 1 minus cosine x. All right, the first thing I see is LCD, yeah? Right. Well, there's no formula for 1 plus cosine x, 1 minus cosine x. Remember, I know that you're eager to use a formula, but all the formula up here, when you see them, they all have what? They all square, right? We don't have any square here. So we cannot use it yet, not yet. See if we ever use it. So LCD, so the only way I can think of is LCD. What should I multiply the first fraction with? Yeah, 1 minus cosine x, right? 1 minus cosine x. I'll put the parenthesis around the original one. And then the second fraction, 1 plus cosine x over 1 plus cosine x. Now, I have a common denominator, which is 1 plus cosine x times 1 minus cosine x. And the top is what? The top is 1 minus cosine x. And then I'm going to distribute the 1. Well, the negative 1, actually. Don't forget that negative there. So basically, I'm distributing negative 1 into the blue binomial. So negative 1 times 1 is negative 1. Negative 1 times cosine x is negative cosine x. 1 and negative 1 cancel. Negative cosine x minus cosine x is what? Yeah, negative 2, right? No, I hope nobody multiplied them, right? We have operation is subtracting and addition here. So equal minus 2. Think of it as 1 here, 1 here. Minus 2 cosine x. Now, the bottom. Do you see anything familiar about the bottom? In terms of Euler algebra, what is that? Yeah, a plus b times a minus b, right? Here a is 1 and b is cosine x. So this becomes what? A squared minus b squared, so that'll be 1 squared, which is 1, minus cosine squared x. What's 1 minus cosine squared x equal? Sine square, right? Sine square x. Minus 2 cosine x over sine square x. We're nowhere near the right hand side. Let's do some more. For sine square x, can I split them into sine x times sine x? Is that okay? Is that all right? It's the same thing, right? It's like x times x is x squared. Right? What is this equal to? The one in the green bubble. So negative 2 is negative 2. Well, yeah, that's cotangent, right? Cotangent x. And I can put the 1 here. It is, there's a 1 there with the invisible 1 there, right? It doesn't change your expression. And that, sorry. And that bubble will be cosecant, right? Cosecant. There you go. That's your right hand side. Sorry. That's the multiplication, not. So far, so good. I know it takes a lot of practice. Don't be nervous if say, oh my God, it's a lot of information. It take practice. For number 8, what side should I pick? What side do you think I should pick? Right hand side, right? Look like right hand side is a good call. Cotangent square of x over cosecant x minus 1. What should I do next? First thing first, you see cotangent square x. You look at the identity, see if I can convert. Let's see, cotangent square x. Where is it? Maybe here. It doesn't matter. I guess it doesn't matter which one you pick really. That one, right? That one, yeah. All you have to do is subtract one. Is that okay? So cotangent square t equal cosecant square t minus 1. Let's do that. Let's do that. So cotangent square x equal cosecant square x minus 1. Let's take care of the top. The bottom is nothing we can do. Well, how can I factor the top? Well, the bottom is just rewrite it. It's just not. Someone factor the top for me. Yeah, that's it, right? So let's see, and minus the reason I know I'm being repetitive. Well, the reason that I want you to repeat it yourself so you remember on the exam. It become part of your memory, like it's like muscle memory. Right? You see it, you know right away. Cancellation. Cosine x plus 1. All right, I'm nowhere near the right left hand side. Any suggestion? Cosecant is related to sine, right? So let's keep going. So this is 1 over sine x plus 1. What is my common denominator? Yeah, sine x over sine x here. Now equal 1 plus sine x over the common denominator, which is sine x, which is your left hand side. Number 9 is your u try 2. Use the hint they tell you, use the hint. If I don't, let me tell you, u try 3 right now. So in case I don't finish the. If I don't finish the last page, I still going to post the answer for you. Okay, I have it at home. I did it, but just in case. Number 10. I will pick the left-hand side. One over 1 minus psi x plus 1 over 1 plus psi x. Maybe I'll leave a little space because I know that I'm going to multiply with common denominator, the LCD thing. I think we did this before, didn't we? Okay. Sort of. 1 plus psi x over, oh, that was cosine, 1 plus psi x. And for the second fraction, 1 minus psi x, 1 minus psi x. On the exam, I see a lot of people use silly point because they forgot the parentheses. And then at the next step, or you only distribute the psi, but not the 1. Right? Now we have it one common denominator, which is 1 minus psi x times 1 plus psi x, which is, if you ask me, what is that? Let's take out the bottom, which is what? A minus b times a plus b, right? A squared minus b squared. So 1 squared, which is 1 minus psi squared x. One more time. What 1 minus psi squared x equal? Yeah, cosine squared x. We'll stop it there for now, right? Let's take care of the top. The top is 1 plus psi x. Distribute the 1 and it's positive, so it's okay. So plus 1 minus psi x. D2 is cancel. 2, 2. 1 plus 1 is 2. All right, I think I did something wrong. Maybe I did something wrong. No, I don't do anything wrong. No, nothing wrong. The thing is I'm stuck. I look at the right-hand side, like, oh, I'm nowhere near that. And I have no idea how to make it into like that. Well, if you run into that problem, what I suggest you do is we're gonna work at both sides at the same time to see if it arrives at the same answer, right? So let's do the right-hand side, see what happens. Let me put this guy down here. Sorry about that. Let me put it right there, so I can use my right-hand side here. 2 plus tangent square x. Remember one of the thing about identity, you look at the other side of the identity to get an idea of approach, right? All right, the right-hand side. Yeah, thank you. So the first thing I see, I'm going to factor out the 2. Is that okay? That's my first reaction. I see common denominator. Sorry, common factor. GCF. Right? What's 1 plus tangent square x equal? Yeah, secant square x, right there. It's just 2 times secant square x. And secant square x is the same thing as 1 over cosine square x. This is 2 over cosine square x. There you go. Now you can say left-hand side equal to the right-hand side. I want you to try number 11. Try it yourself. See how far you can go. Apparently, we're going to pick the left-hand side. See how far you can go. If I was you, I'll start at the denominator first to get the idea to how to start with the top. But don't be afraid, I'm not expecting you to give me an answer. Some of you get the jig really fast, so which is good. Right, so that's you. So fact the bottom I factor out tangent theta. I have side theta minus 1. Now for the top, initially I was like, okay, I'm gonna use the Pythagorean identity, right? That's what I thought. But then I see the bottom after I factor out the tangent theta, maybe I don't have to use that, right? Maybe I can expand it instead into a 2 binomial. That's a squared minus b squared. So 1 squared is still 1. So a is side theta. So a plus b side theta plus 1 times a minus b side theta is minus 1. Cancel, cancel. Then you're done. I'm going to stop here. I'm going to post the last page for you. All right, have a good one, and I'll see you on Friday.
I had a question
Yeah.
just before the exam. So for using our computers for the p-value, are we just going to do that for the paired means?
Yes,
Okay.
for the pyramid.
So exactly what we did like on the notes.
Yes.
Okay, thank you.
That's the only thing that I don't show you do by hand.
Okay.
Oh, I know. One of my students emailed me. I'm like, I'm sorry, I couldn't make a decision.
Yeah,
That's
so
from university.
So I may or may not be able.
Okay, I understand. I understand.
To have office hours. I just want to
Yes,
make
I
sure.
do. Yes. Unless
So
the university closed, yeah.
Okay, thank you.
You're welcome.
So on the sheet, this is the formula for it, but on the notes, this was.
This
the
is, let me see, let me go back. It is, oh, sample cycle module. They have sigma here, a little bit different than us. I think, oh, so this one is for the regular complete interval. This one is for conservative.
Okay,
And this one is for population mean. This one for population proportion. Does that
okay,
make sense? So on your problem, depend on if you want population proportion, then you want to use this.
okay. So then what about this?
That's proportion, right?
Yeah.
Population proportion,
Right.
which is correction, which is the same thing as this. I remember
Oh.
I derived it last time.
Oh,
So
okay.
you plug in 0.5 here. 0.5 for P star, right?
Mhm.
1 minus 0.5 is 0.5 again. 0.5 times 0.5 is 0.25, right, which is 1/4.
Mhm.
Right? So 1/4 is same thing as 1/2 squared.
Right.
So they put 2 here.
Okay.
Yeah, they just make it more complicated than
Okay.
it should be. Yeah. Extra 1, 2, 3, 4, 5, 6, 7.